The ultimate guide to system parameter permutation. First, let me share some stories with you. Maybe it's gonna click. So maybe you're just starting trading, you fund your account, you buy some stocks, sell some stocks based on some gurus. You follow them, you get the signal, you buy, you sell, you make some money. And for whatever reason, the market crashes and you lose all your money. Because those gurus are right when the market is going up. Because the tide is up, it lifts all the boats. So any stock you buy, if it goes down, just hold it enough time and it will start to go up. Because that's what bull market does. It lifts everything up. So then after the market crashes, you think, the hell with these guys. I was stupid to follow them. So then you start to read. And maybe you are technologically savvy, so you tinker with some software, or maybe you are a programmer. And you start, follow some systems that are in these books. And you build a system, you think, now it's computerized. I must be now on the right track. You run it, you fund the account, you run the system, and you blow up. And then you meet some friend and, you tell him about your story and he think, you're doing it wrong. You see the crossover, moving average crossover system. It's not 20 and 50. It's 21 and 55 because those are Fibonacci numbers. And you think, yes, that's what I missed. Fibonacci, math, science. I am a math guy. I am an engineer. I think this will work. So you change the system and you see it makes some money. You run it a little bit in demo mode and it still makes money. You fund the account, you trade, it goes up a little bit and then down. You lose all your money. I just want to show you that this is the illustration you're going through. You develop a system like this, but the outcome is always like this. So now you take another course, maybe you read another book, and you found out that there is in sample and out of sample. Makes a lot of sense. You test on in sample and then you test on unseen data. Makes total sense. And you build a system. Of course, it's totally overfit, but you don't know. You're just starting, or you're in the middle of your journey. You don't know. So this is totally overfit system. But thankfully, you don't run it because you meet another guy and you say, look, this is overfit. What you need to do is a walk forward optimization because that's multiple in sample out of sample, and that will not be overfit. Total crap, it's still overfit. Even the guy who invented walk forward optimization, Robert Pardo, he will tell you that this is totally overfit. This is just one outcome out of 1,000. You don't know because you never met Robert Pardo and you never met Ali Casey, so you don't know. You put the system on, fund the account, trade something, blow up. So then you think, okay, the market is rigged. Obviously, because you're not making money. You don't know anybody around you who's making money. I mean, yes, you go through periods where you're making money, but you're always ending up down or zero. Then you leave the market, you get out of it, you don't invest, and you lose the opportunity to grow your wealth, which is really sad. See, everything you're doing is, regardless if it's overfit or not, you don't know because you're picking like just one single outcome. So this is the problem. The problem that out of all these curves in the future, you are picking the best one. But you can see there are thousands of other outcomes. Of course, I didn't draw 1,000, but you get the idea. There are thousands of other outcomes. The chance that you're going to have this one out of 10,000 is 1 over 10,000. And the chance of this one over 100,000 is 1 over 100,000. So you see that the probability is really low. It's almost zero basically to get the same outcome that you've seen before. So we need to find a way to give us a practical expectation. I don't want to be over optimistic and I don't want to be very pessimistic. I just want to know, how closely I will match this in the future. And there are many ways to test this. So we will see what's available in SQX, and of course, as the title of this video, we will focus on System Parameter Permutation, which is SPP for short. If you are new to this channel, make sure to subscribe, hit the notification bell so you don't miss any of these valuable videos. And as always, I do appreciate it to destroy the like button. this will really help the channel grow, as it helps Google to push this video to others. And really, would it hurt you to share the video on your social media? Really? Facebook, Instagram, Twitter, whatever group you have, Discord, just share the video. Can you do this, please, for me? Really, I appreciate it. Thank you very much if you do that.
And now back to your regularly scheduled program.
So in StrategyQuant X, this is the cross-check robustness, and you can get to this in Retester and in Builder. And basically, you can automate it with custom projects also. So like I showed you, the Monte Carlo, it basically randomized the trade results. The problem with Monte Carlo is garbage in, garbage out. Also, there is another problem with Monte Carlo, is when you shuffle the trades, the financial markets, the distribution is actually not like any other market. So we can easily see that the volatility is lumped in certain times. So you don't see the volatility distributed evenly over the time series. So when you use Monte Carlo to randomize these trades, the volatility will get distributed evenly, let's say. So you lose that lumpiness. So that's another drawback on Monte Carlo. Also, all the noise and the reshuffling you add in Monte Carlo, it's actually not going to change the parameter values. So let's say you're doing the moving average crossover. Let's say you're doing 20 over 100. You're going to shuffle the trades. You're going to add noise to the price in, price out. You're going to resample some or all the data. You can do many things in Monte Carlo. But the only thing you're not going to do is change the parameter value of the moving average. You're not going to go and say, oh, instead of 100, let me test 90 now. Let me test 60 now. So that's not in Monte Carlo. And then we have the walk forward and walk forward matrix. But like I mentioned, I'm going to emphasize SPP right now. So what is SPP? So SPP was invented by Dave Walton. He won actually the Wagner Awards for it in 2014. So it's based on a white paper, and you can find the white paper on SSRN. Now, SPP actually is a simplified version of stochastic modeling, which is used heavily by insurance companies and sophisticated hedge funds. Now, why it is a simplified version? Because stochastic modeling actually requires a lot more powerful computers and a lot more powerful programming ability. Still, SPP is beneficial, though it's limited in its implementation, but we can still use it and benefit from it. So at the core of it, SPP changes the parameters of your system. So let's say you're taking the crossover of 20 over 100. So it will change 100 up and down, 90, 110, 80, 120. It will change 20 up and down, 15, 25, 10, and 30. And it will test all the combinations. Okay, and then if you have, let's say, an exit of 10 bar, it will change 10 bar, 9 bar, 8 bar, 11 bar, 12 bar, and so on and so forth. So it will come up with, it will change all the parameters up and down by a percentage. It will do a simulation of all the combinations, and then you will have a distribution of all the KPIs: maximum drawdown, net profit, consecutive winners, consecutive losers, profit factor, you name it, it's all there. I mean, whatever SQX have, but all the parameters in SQX, it will be calculated for each simulation. And then it will draw a distribution of that simulation. After you have your distribution, you calculate the median, which is not the average. So the median is the middle. Actually, the target of it is that your future expectation should be the median. So let's say you pick a strategy. Your net profit is 10,000 and you do SPP, and SPP comes up with 6,000. So then it doesn't matter what your strategy is and how good and robust, blah, blah, blah. Your expectation in the future should be close to 6,000. It might be less, it might be more, but it should be close to 6,000 and not 10,000. That's a very optimistic view of the future. So that's the target of SPP. Very important to note here that the median in SPP is just the expectation in the future. So you should not take the median and find out, oh, okay, now let me see what the median is, and let me take the parameters, the values of those parameters, and put it in my system. That's not what the median is. The median is just the future expectation of your strategy. Okay, so how do we implement SPP? So you have your system and you come to the cross-check and you go and you pick it. And then here you will find either recommended parameters or your own settings. If you don't know what to do, then just pick recommended parameters and don't pick 500. I'll tell you why in a second, but pick minimum 5,000 and the limit is 20. So after 20,000, so this is 20, and if I do 21, you will get a 20,001, you will get this warning. And then you have filtering, and this is related to distribution, and I'll come to it in a second. So once you have that, you save it and you run the strategy. So this is the strategy and I run it, and this is the system parameter permutation. We have a set of KPIs here, and of course you can build your own KPI here. So you can add all KPIs for SPP here and here. And the way to do it is, let's say we want, I don't know, let's say consecutive wins. And then we add it, we come back. So this is average consecutive win. And then if we want to add it here, so you go, but here you need to pick SPP. Here it already knows it's SPP, and here we need to go to the main data and pick system parameter permutation. And when you pick this, it will pick the median, and you can see here is the median, but you can see it's 511, and you can see here the median value is 511. So for example, the net profit, this is the amount, this is the amount and the frequency, and this is the median. And we notice that our strategy is way above the median. That means our strategy is not robust because we have really high expectation that we're going to be there while we are here. Then we look at the drawdown. The median drawdown is 29 and we are at 14. So again, this is very optimistic view of the future. We can see that we can, view it like this, and it's really easy to determine. But of course, we need some math way to do it, and we can do that in the testing. So in the testing, you can implement filters. So here, for example, I have this filter. So the net profit of my original strategy is smaller than the net profit of the SPP at 110%. So I am looking for my net profit to be less than 110% of the median. So then I can filter on this mathematically instead of coming here and looking at the results. Also, we have the other filters which are built in, which is the best optimization profit is lower than 2 standard deviation of the average profit. Now, of course, I love to have the median instead of the average because the whole paper is based on median. So I don't know why SQX built it on the average, but anyway, it's there. But we can build our own here. So you see, SPP is giving you the expectations in the future. It's drawing a cone of all expected curves in the future based on changing the parameters value up and down. So it's not shuffling the trades. It is actually changing the parameters value. And based on that, it will give you a median value. And then you can compare whatever you have to this median value. If you're close to it, that's fine. Then your expectation is within the future expected value. Okay, so now we understand what SPP is, who designed it, how it is working, and how it is working inside SQX, which, by the way, is the only retail package that I know that has implemented SPP. So we need to be careful of some things before implementing SPP. First of all, if your strategy have a single parameter, then SPP will do nothing. because SPP needs to have thousands of iterations to come up with a good conclusion. And if you have a single parameter, you cannot come up with 1,000 variety. Also, from that perspective, you cannot bring in a strategy with, 15 parameters, because then the combinations will be a million, a trillion. And then since you're only limited to 20,000, so then whatever you're doing is you're taking a subset of that million combination, and then that 20,000 is not a good representation of that million. So that's also a limitation. So you cannot test a few parameters and you cannot test too many parameters. You need to be in this sweet spot between 5,000 and 20,000 combinations. Of course, if your strategy is 40,000 combination, that's still good. You're 50% of the total population. Also, you need to define the parameters intelligently. And what do I mean? So say you have the moving average crossover system, 20 and 100. You cannot change the 100 randomly to starting from 40. That doesn't make any sense. Taking this to the other extreme, you cannot also change it with 2%, because that also doesn't make any sense. 2% is very low on the moving average. And like I mentioned this already, the median output is an expectation of the future result. So it's not the median parameters that you need to put in your strategy. So your strategy parameters will stay the same. It's just the median is the expectation of the results. And also we have some limitation in the implementation of SPP in SQX. So let me show you that. And the limitation in SQX is, for example, you have recommended, but if you do your own, you can of course pick and choose the parameters, that's fine, but you cannot pick and choose the ranges. So for example, if you go to walk forward optimization, you see here you can pick the distribution from the original value. The inside, the parameters, the periods, the constants, I am picking a percentage of up and down. So I want this to be in SPP. So this is for SQX to implement it, because we need to be able to limit the up and down and the maximum number of steps inside the permutations. And also, of course, the other limitation, which is the number of tests, like I mentioned, is 20,000. Actually, I don't know the limitation if it's in the program or in the hardware, but hopefully also that can go up a little bit. So for people with powerful computers, they can use that up. And also, Dave Walton, the guy who invented SPP, he later on came up with a better version, because like I mentioned, this is a simplified version of the stochastic modeling. So then he enhanced SPP with putting Monte Carlo on top of it, which is really a great idea, because you can because SPP will do all the permutations by changing the actual values, but then Monte Carlo will just reshuffle those. So that actually, instead of doing a million simulation, you can build 20,000 through SPP, and then you can put Monte Carlo on top of SPP to shuffle those, so you get also some of the outcomes in the original million. So you understand that. So you, instead of doing a million, you do, let's say, 50,000, and then on the 50,000 you shuffle it through Monte Carlo, and then that will get you closer to the 600, 700,000 iterations of the simulation. And he actually did test on it and found out that Monte Carlo actually do bring you closer to actually doing the million iteration. So hopefully that will be implemented in SQX also, because then that will really bring it home by just giving us the option to limit the range and the percentage, and by implementing Monte Carlo on top of it. So there you go. That's the whole system parameter permutation. That's everything about it. And you should be now an expert in implementing SPP in your workflow. As always, if you have any questions, please do comment below. I'm sure because I get this question many times in the Discord server anyway. So I'm sure you're going to have some questions. Do comment below. I'll be happy to answer all your questions. Of course, I'm open to the emails also, direct email, or directly through the Discord server through the Patreon link down below. As always, I wish you the best of luck in your trading, in your investing, and stay safe, and I'll see you soon.